Good morning.
Morning.
All right, how are you guys doing today? It seems like the week is going faster this week than last week. I don't know why. And I forgot to plug into my Ethernet, so if it gets bad, I'll have to pause and plug it in. So while we're waiting for more people, let's do our warm up. So it's another or probability. Suppose we draw one card from a standard deck. What's the probability of getting a face card or a heart? Can you see my screen? I hope. Yeah. Okay, good. So try that and you can get it ready in the chat. And it says fraction, decimal, and percent. If you wanted to be super fancy, you would write your probability statement too, right? But at least do the answer. And don't hit enter yet. I'm hoping we have more people coming than this, right? I know I was a little late to log in. My cats were having some sort of attack, so I had to deal with them first. I know. So I have my balcony and the cats were both out on my balcony, and that's not going to last, right? Because it's going to get too hot. So I opened the door and they both were just looking at me like, are we doing something wrong? And I was like, get in here. So that took extra time that I was ill prepared for. All right. So try that warm up that you see on your screen. And after a little bit, I'll have you put it in the chat. We're still missing 1, 2, 3, 4 people. That's weird. Okay, do you guys have your answers ready? All right, let's do it in the chat. Just a 3, 2, 1 to everyone. 3, 2, 1, go. All right, so far so good, right? Everybody's the same. We do have a little discrepancy here on our decimal. We have a couple people that put 0.423, and then we have a couple people that put 0.4231. I didn't say how many decimal places, but what do we usually go to? Yeah, we usually go to 4. So probably more would ask you for 0.4231. Okay. So, and make sure you give me all three: fraction, decimal, and percent. Okay, so if you were writing down that probability statement, you would write probability of a face card or a heart. And so you do probability of a face card plus the probability of a heart minus the probability of a face card and a heart, right? And you all got it correct, so you must know how to do that. Okay. So this is the kind of thing that would be very helpful if you did it on your show your work part for your test, right? Also, I have some exciting news too about your probability review next week, but hopefully I'll wait till those other 4 people get here so we make sure everybody hears all the directions. Okay, so any questions or anyone have anything to share on We Share Wednesday? Olivia's sharing her puppy. Isn't it going to be sad when you have to go back face to face and your puppy can't sit on your lap when you do school? Yeah, I'm telling you, we've gotten a little tricked here with, we think we don't like online, but we actually may, right? Like sometimes in between classes, I'm changing laundry. That's very convenient, right? Whenever you're hungry, you can just walk and get a snack. That's very convenient. But I do miss having students in class face to face. Did anyone register for fall already? Or summer? Anyone needs summer classes or fall classes? The schedule's up, right?
Summer classes.
What?
I'm taking summer classes.
Nice. And you got all registered, no problem?
I actually did have a problem. I had to contact my advisor, and she had to contact admissions, and they had to add the classes for me.
I wonder why. What did they say was wrong?
When I went to add the classes, it's supposed to say spring Mesa Community or summer Mesa Community College, and it didn't. And then I went to apply for admissions again, and then it wouldn't allow me. And then she said that they couldn't do it on their end either. So then she had to contact someone else, and then they did it for me for some reason.
That's weird.
She said it was weird too. But yeah, I couldn't get the classes on my own for some reason.
Okay, so make sure you try it so you get in touch with your advisors, right? If you need to, like Yesenia said. And if there's a little glitch, it wasn't too hard, right? Yesenia, you got it handled?
Yeah, it wasn't too hard. I'm guessing maybe it had something to do with the cyber attack. I don't know.
Yeah, no one knows. We don't know. But yeah, hopefully it's all fixed. I do notice that, like, because I can see my classes, which is funny because it still doesn't have my name attached to them. But if I search my name, my classes come up. Does that make any sense? So if I search my name, my classes that I'm teaching come up, but my name's not on them. So I don't know how it's finding me. It's a little weird. So all my classes still say staff as the teacher. Random. So yeah, I'm hoping they update that soon, but I think they're having some issues. Anyone else have anything to report? Good, bad, indifferent? All right. Well, let's get started, and then I'll share what I want to share as hopefully we have everybody arrive soon. Okay, so you did your mini lesson last night. I will admit that I did not redo my mini lesson, so I'm not sure if you guys saw this, but I'm guessing you did. We have a new calculator available to us. Did you guys see it? I'm going to put it in the chat. You don't really need it ever, but it's a kind of a nice way to double check things. So I'll show you what it looks like, and then we'll talk about when we will use it. So it looks like this. It's called a factorial combination and permutation calculator. So N is the number of things you have, and R is the number of things you're choosing. And then N factorial, we'll talk about what that means. And then NPR and NCR are formulas for permutations and combinations. And that's all we have left in this probability unit. So today we're going to talk about the basic counting principle and permutations. And then Monday and Tuesday we'll talk about combinations. And then we're done. So also I opened all of next week already. Did you see that? I just did it before class. So if you weren't on, you might not see it. So I opened all your more assignments and all your paper assignments. So you could work on those in advance if you want, because I don't want that quiz to sneak up on you, right? So if you want to work ahead, you totally can. All right. So we're going to do some examples, and I do have a worksheet for those examples. So if you want to follow along, they're all on the screen, but I just want to make sure you have them if you need them. I just have to figure out which worksheet it is right here. Here we go. Here we go. Okay. So these problems are a little bit different, but they're related to what we were doing. So this is the worksheet. And first we'll talk about the basic counting rule. So if we're asked to choose one item from each of two separate categories, where there's M items in the first category and N items in the second category, then the total number of choices available are M times N. Sometimes this is called the multiplication rule for probabilities, okay? My favorite example of these is not this. So I'll talk about my favorite example first. Have you ever watched the show What Not to Wear? Did anyone ever watch that show? Yesenia's shaking her head, yes. Anyone else watch this show? That's so sad. It was such a fun show. I don't even know if it's still on, but it was a fun show, right? Okay, so Yesenia can back me up. It is a real show. I didn't make it up. It's not from the 50s, I promise. Okay. So, and what this show was, somebody nominated another person for the show, like your best friend nominates you. And the nomination is actually kind of hugely insulting, right? Because it basically says you dress horribly. Okay, so the show's called What Not to Wear. So you come on the show, somehow they get these people to agree. I'm not sure how. And then the first thing they do is throw away all their clothing. Yeah, like all of it. They get rid of all of their clothing. Now, if you've ever watched the show, Yesenia, I hope they're donating those clothes, right? I hope they're not really throwing them away because that always bothered me. But Then what they do is they shop with these people, right? And they buy them new clothes and they change their hairstyle and whatever, teach them how to put on makeup and things, those kind of things. And then at the very end of the show, this is what relates to math, just in case you were wondering where we were going with this. At the very end of the show, they bring out their new clothing, right, on this rack. Okay, like a clothing line, right, with all their stuff hanging, and then they have like some shoes and maybe some scarves, and they tell you, oh, there are 720 outfits. Let's just say, and you're like, what? What? There's like pairs of pants hanging there, right? There's like 4 pairs of pants, 5 shirts, maybe a belt, a couple pairs of shoes, and a scarf. And you're like, how are there 720 outfits? Yesenia, did you ever wonder that? How they got so many outfits?
I did.
Yeah, it's a kooky thing. Well, they were using this basic counting principle to figure out how many outfits there were. So what they were doing was they were taking how many pants or skirts, whatever it was, times the number of shirts or blouses that they had, times the number of shoes that they had, and then maybe times the number of scarves that they had. So they were multiplying all those together and saying, that's how many outfits there are, because that's how many different ways you can put these things together. That's the basic counting principle. Like they're saying here, just multiply the two together. So I don't know about you guys, but I seriously do not believe it's a whole new outfit if I just change my shoes. Right? So I'm pretty sure that show was lying to us the whole time. Okay, but that's what I always think of when I think of the basic counting principle. Another example you can think of is, have you ever been to a pizza place and they have different sizes of pizzas, right? Maybe they have a really small, a medium, a large, and then an extra large. So those are 4 different sizes of pizza. And then they have 12 different flavors of crust. Has anyone been to one of these crazy places? I always think of Hungry Howie's or Gino's Pizza because they always have tons of flavors of crust. They're like herb, garlic herb, butter, garlic butter, original, original with butter, original. And you're like, what is happening? I don't even know any of these choices. So 12 different flavors as crust is a little extreme, in my opinion. And then 10 different toppings seems normal, right? Because you could pick pepperoni, sausage, mushroom, green pepper, black olives. So you could think of 10 toppings, 10 crusts I'm going to have a stretch coming to. But do you see it says the question is how many one topping pizzas can be ordered? Well, we're just going to use that basic counting principle and we're going to say there's 4 sizes times 12 different crust flavors times 10 different toppings. And notice we're only choosing 1 from each category, right? So that it's not saying 2 topping pizzas or 3 topping pizzas because that changes our mathematics. We're just picking 1 from each one of these categories. So if we multiply all these together, what do you get when you multiply 4 times 12 times 10? What you guys get? Anyone? There you go, 480. Is that insane? There's 480 different one topping pizzas that you get. Now, mind you, what this is saying is if you get a small, regular, like regular crust pepperoni, that counts as a different one than a medium, regular pepperoni, which counts as a different one as a large, regular pepperoni. Do you see? That's why there's so many. Makes sense? But so if it asks you how many one topping pizzas can be ordered, that's what we're doing. We're using this basic counting principle. Okay. So I want you to think this one through and see if you can make sense of it because this one's a little bit different. It says standard automobile license plates in a country display one number followed by 2 uppercase letters followed by 4 numbers. So I'm just going to draw something that might help you make sense of it. So we have one number. So this is a number. Then we have 2 letters. These 2 are letters. And then we have 4 numbers. Oops. These are all numbers. Think about this problem for a minute, and then we'll talk about it and see how many different standard plates are possible in this system. Okay, so think about that for a minute. What would you write in those blanks?
Is there 26 numbers in the alphabet?
Yep, there's 26 letters in the alphabet. Yep. All right, so you guys thinking of what you would put in these lines that I drew? I know that AJ was thinking about it and Valerie was thinking about it. So these are like the different things we're filling in. So how many numbers do I get to choose from? How many digits are there?
It would be 0 through 9, so 10.
Very nice. So there's 10 digits possible here. And that's going to be true for all of these, right? Because do you see how it says repetition of letters and numbers are allowed? So it's okay. If I used a 9, I can use 5 nines if I want. It doesn't say I can't repeat it. So if it says repetition is allowed, that means I can use the same thing again. If it says repetition is not allowed, then I would have to get rid of the number that I chose, right? Okay. So there's tens in all of those spots. And then Valerie helped us out that there's 26 letters to choose from. Do you see why I'd put 26 in each one of those blanks? So then to figure out how many possible license plates combinations there would be or different ways to put them, I would multiply all of those together. Okay. I would multiply 10 times 26 times 26 times 10 times 10 times 10 times 10. That's a lot of license plates, right? Which would make sense because we have a lot of cars. Okay, so did you get that for an answer? 67,600,000. Any questions on how we got that? Does that make sense to you? Okay, good. Now I'm going to let you try these. Okay, and I'm going to put you in your breakout rooms, and then I'm going to bring you back and have you explain them. Okay. All right, so let's put you in your breakout rooms. I think there's 2 if I pull up that worksheet. If you want to work on more, you can. You're doing, I feel like that's not, the handout that I gave you, did it even match what we were talking about? Yeah, what is happening? Did I lose my mind? I thought it did. Let me see if it does in a minute. A boy owns 2 pairs of pants. Oh, maybe we'll just stay here and do it since it's not on that handout. Maybe this is my handout for tomorrow, even though it says it's my handout for today. Weird, weird. Let me see if I can find the handout that fits. But do the problems that you see on your screen. How's that? Let's do those problems that you see on your screen, not on that handout. Are you still working? I don't want to rush you. Now that I finally gave you the right document. It's these two on the screen. Are you doing okay? Do you have answers for both of them? All right, who wants to explain the first one? A boy owns 2 pairs of pants, 3 shirts, 8 ties, and 2 jackets. How many different outfits can he wear to school if he must wear one of each item?
I got the answer 96 outfits.
Anyone else get 96 outfits? Aaron shaking there. Nice, a lot of you. So what did you do with it? So what did you do with those numbers to get 96, Olivia?
I multiplied each like article of clothing. So I did 2 times 3 times 8 times 2.
Very nice. So this is the basic counting principle. How many choices do I have for a pair of pants? I have 2 choices. Then how many choices do I have for shirts? I have 3 choices. How many outfits do I have for ties? 8 choices. And how many outfits do I have? How many choices do I have for jackets? 2 choices. So this is all the different ways I can put them together. Obviously, you can see that I'm going to have to wear the pair of pants more often, right? And the shirts and the jackets more often, whereas I can change the ties less often because I have more ties. This seems a little more reasonable for this type of attire, right? This type of clothing. That changing your tie could be changing the outfit, whereas other types of clothing like dresses or skirts that might not be appropriate. Did anyone wear uniforms in school? Did anyone go to a school that had uniforms? Yeah. So several of you did. This is probably pretty close, right? So you didn't have, especially as females, if you had to wear a skirt, you probably didn't have 5 skirts, right? You probably didn't have 5 different skirts to wear one each day. You wore that same skirt more than once. My kids go to a uniform school right now, and my daughter has 2 skirts, right? That she rotates those skirts because those skirts are expensive, man, and nobody likes them, right? So you might as well just only buy 2 of them. So the basic counting rule says we multiply these together. So we get 96 outfits. Jen Day, that might have been before you logged on. That was the basic counting principle from up here. The basic counting rule, we multiply the 2 together. Does that make sense? Okay, good. So now how about the second one? This one was a little more complicated because it says all the license plates in a particular state have 3 letters and then 3 digits. How many different license plate numbers are available if you can repeat? So did anyone get an answer to this one? There'll be a lot of them, right? What'd you get for an answer for this one? Oh, Valerie put it in the chat there. And just so you know, very nice. And Aaron put it in there with commas. So notice that every time you have 3 numbers together starting from the right, then you put a comma. Okay. Believe it or not, those 3 numbers together are called periods, even though we put commas there. It's a little annoying. They really should be periods there, right? But then we'd get confused with decimal places. Did anyone grow up internationally? Because internationally, they do it the opposite of how we do it. They do put periods there, and their decimal is a comma. Weird. So if you meet someone who didn't grow up in the United States, their mathematical notation might be a little bit different when they write numbers. So I agree with you, 17,576,000. And how you did that was you multiplied, we had letters first, so 26 times 26 times 26, and then 10 times 10 times 10, and we multiplied those all together. It's nice. Do you think this is useful information to know? Why do you think we would need to know this? Anyone have a reason? We just had a very specific reason with MCC. You all had to reset your passwords, right? And there's criteria on your passwords, aren't there? It had to be 12 characters long. You had to have 1 uppercase. You had to have at least 1 uppercase. Then you had to have a symbol and a number, right? So making those criteria on your password, we need to know how many combinations there are. First of all, for cybersecurity, that was one of the reasons, but also they need to make sure they have enough for all students, right? To have unique passwords. Think about your MEID, right? So most people's MEID is 3 letters and then it's a group of numbers, right? So they have to determine how long that is. Is anyone old enough to remember in Arizona when we all used to have the same area code? Everywhere in the state of Arizona, it used to be 602. Did you know that? Yeah, and it wasn't that long ago. I'd have to look it up when it changed. But every part of the state of Arizona, the area code was 602. No matter if you were in Flagstaff, Kayenta, Tuba City, Sierra Vista, Nogales, Arizona, it didn't matter. Everyone had a 602 as their area code. Yeah. Then it changed. We have an area code for up north, right? 928, right? So we have 928. For Tucson, we started 520. In Phoenix, we had 623, 602, and 480. So now we have all these different area codes. Why? Why did it change? You used to not have to dial 10 digits. You only had to dial 7 digits. Why? What happened? Any ideas?
Did we start to run out?
That's exactly what happened. Arizona's population grew so much, we were going to run out of numbers, run out of possibilities. So they had to create these new area codes, right? Which made a huge difference. Then we had a lot more possibilities. Interesting? Maybe, maybe not. I don't know. It depends on what your job is, right? Some people find it interesting, but some people do not. All right. So there's just my solutions written out for that. So the next one on your worksheet, the corrected worksheet, by the way, if you pulled that up, the next one talks about a true false test, contains 13 questions. Have you ever thought about how many different ways the test could be answered? Yeah, that's kind of an interesting question. So I want you to think about that. 13 questions. It's a true false test. We don't care if they get them right or not. We just want to see how many different ways they could answer it, right? So for example, someone could put all true, right? Someone could put all false. But then we have all these options on each one. I want you to calculate how many different ways this test could be completed. And then we're going to put our answer in the chat. Okay. Don't hit enter until I say. All right, are you ready to put your answer in the chat? Let's see it. 3, 2, 1, go. Very nice. Look at that. Yeah, so, and sometimes, I don't know about you, you can decide, but through section 6 and 7, PC6 and PC7, I like to have these, whoops, I like to have lines drawn so I remember what I'm doing. So since there's 13, I'm going to draw 13 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then since they're all true, false, I would just put 2s in each of the questions because I could pick true or false on each one of these. And then you're just going to multiply them. Now, on your calculator, you could take a shortcut because I don't know about you. Did anyone get lost counting their 2s? Yeah, it's hard. There's a little caret button on your calculator, or you can do an exponent or a power. So it's 2 to the 13th power. I'll show you what it looks like on our Desmos scientific calculator. So if we hit a 2 and then we hit this button right here, it makes a little exponent, and then I can hit 13. And do you see that's the answer everybody got? 8,192. Yeah? Anyone have questions on how to do it on their own calculator instead of the Desmos calculator? Everybody okay on where to find it? All right, now I could make this question more complicated, right? I could say, what if there's two true false questions, and then there's 3 multiple choice questions with 4 answers each? Do you see how all you would have to do is just change how many choices you have for those questions? So just because I'm doing one example doesn't mean there couldn't be a ton of different ways they could ask you the same idea on more, right? Okay. Let's go back here. This is what we were just talking about. A computer password must be 10 characters long. How many passwords are possible if you can use 26 lowercase letters and 26 uppercase letters? And so they're all allowed. So you have to be careful on questions like this because they're telling you something new. What they're telling you is that this letter counts as a different letter than this. An uppercase A and a lowercase a is different. This is what we would call it's case sensitive. Have you ever heard of that before? If it's case sensitive, so meaning it matters if you have a capital A there or a lowercase a there. This is your password for Maricopa is case sensitive, right? So it matters if your cap locks is on. Have you ever done that on accident? And you're like, why does it say my password's wrong? Because I'm typing it in, right? But it's really your capital letters. So if I have 10 characters here, 10 little slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 26 lowercase choices and 26 uppercase choices. What number am I going to multiply? Or what number am I going to put in each one of these slots? Yeah, Valerie put it in the chat, 52. Where'd you get 52, Valerie?
I add 26 plus 26.
Very nice. If there's 26 lowercase and 26 uppercase, there's a total of 52 choices for each one of these password spaces. So now something might happen on your calculator when you do it. Did anything weird happen to somebody's calculator? They give you a strange answer? Yes, no, maybe? What did it do? I don't know if it'll do it on the Desmos. I'll have to look. Yeah, it did.
I'm using the Desmos right now, and it's giving me like a decimal with multiplied by 10 to the 17.
Very nice. So when it does that, what it's doing, so if we take 52 and then we multiply it times itself 10 times, this is what it gave you, right, Olivia? Okay, did it give anyone else that on their calculators? Yeah, some of you it did. Some of you didn't. What is that meaning? What's wrong? What did your calculator, what problem did your calculator have? Anyone know? it was too big. This is a really big number, right? Do we all agree this is a really big number? So what this means, 1.44555,106 times 10 to the 17th power, is it means it ran out of digits. So if you want to know what it looks like as a regular number, did anyone's calculator say this instead? E17? Yeah, not on Desmos, but on a regular calculator, it might say E17. This is called scientific notation. Do you remember scientific notation? You've heard that word before, probably when you took high school or chemistry or something like that. So what that really means is if I took this number right here, 1.445551059, and I changed it to a real number, that 17 says move your decimal point or your place value 17 spaces to the right. So this is what the number would actually be. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I would go 10, 11, 12, 13, 14, 15, 16, 17. So my number would really be this. Yikes. So what is that? This is millions. This is billion. No, this is millions. This is 10 millions. Millions, 10 millions, 100 millions. So this is billions. This is trillions, right? This is gigantic number. Yeah. So sometimes your number will be super, super big. I don't know that it happens very much on more, but just in case you have that issue, that's what it's doing, okay? And on your test, I don't do any of them that don't fit in your calculator. Okay, so that hopefully it will give you some peace of mind about your test. So if you get something weird like that on a worksheet, you can just write it down. On more, well, if you have any of those that you run into, just let me know. Okay, so I can take a look at them. All right. Now, that's weird. Is this the same one? Ah, here's where your second handout comes into play. I feel so much better. Okay, so we didn't talk about permutations yet, but I'm going to pause for just a second and I'm going to talk about your review assignment. Remember how I said I had something to share at the beginning, but I wanted to make sure everybody was here. Well, now we have more people here, so I'm going to share it right now. So as I said in the beginning of the class, I opened up our entire week for next week. And the reason I did that is because some of you are waiting until the very last minute to do things. And maybe it's because you're crunched for time, but I want to make sure you have plenty of time to get help if you need it in advance. So I'm in our course right now, and I'm going to go to week 12. And you can see that on Sunday, we have, I don't know why that says today. That's weird. I'll change those two. You have a textbook reading for combinations and a mini lesson that are due on Sunday, which is not the 7th, by the way, but I will change that. Then you're going to have PC7 practice. And then you have regular things like when you take an online quiz. You have an info for taking your probability quiz. And then you have your probability quiz and your probability quiz part 2, upload your written work. So these two things down here won't be open until April 15th, and it'll be open from the 15th to the 16th. Okay, that'll be your quiz and your upload your written work, right? And it'll be the same as we took the last one. You'll have any time to take it from 9 a.m. on Thursday up through Friday at 11:59 p.m. We won't have class next Thursday. Okay? You could take it during class if you want to. But this is what I want to show you. You have something new. It's called the Probability Video Review Discussion Board. And you're going to do it with both of my classes. So I have a 9 o'clock class and a 10:30 class. Each person in each class is assigned one problem. Okay? You should do them all because that's how you study for the quiz. But you're going to post one video. So let me see. So here's the directions. First, you're going to click on this document. Hopefully it'll sign you in. So you can see, Jenday, you have to do number 1, the first line. Okay, that's all you have to do for your video. You should do all the problems for the review, right? But the video that you post only has to be for line 1. Valerie, you're line 2. Ashley, you're line 3. Deshay is 4. Yesenia, you're number 2, part A. You don't have to do part B, just part A. Malachi, you're part B. Then Aaron, you're number 3, part A. Olivia, you're 3, part B. Amanda, you're number 4. Amari is number 1 under permutations. Marty is number 2. PC7, AJ, you're number 3. And Angelina, you're number 4. So this is what you're going to do. You're going to make sure you know which one you have to do. You're going to solve it. Then you're going to make a video on your solution. Okay, so you're going to solve it. Now, when you solve it, you need to make sure you explain how you did it, write down your notation and all of that. So if you have a whiteboard, that's a great way to solve it because you can hold it up to the camera, right? You could use a big piece of paper, whatever you want. You can also attach it, but you must make a video. A video is not an option. Okay, you have to make a video. It's going to be super short, right? Most of the time, like way less than 5 minutes. Probably 2 minutes is what I would guess. Okay, and then you're going to be graded not only just on your solution, but you're going to watch the other videos because it'll help you understand probability on all of those problems. And you're going to comment, especially if you think someone did something wrong. Make sure you comment and say, ooh, I did that problem, but I did not get that answer. Yes, this is the answer I got. So you have to post your own solution. Then you're going to respond to 2 other solutions. So let's say someone doesn't do their video, right? First of all, the whole class suffers, so that's not good. But you also have another class, so hopefully the person in the other class with that solution has their answer. And you can respond to any video. It doesn't have to just be people in our class. Okay, it can be people in my 1030 class. So here I did an example. I don't know if it'll actually play here, but all this is, so I'm just showing, this is how you can make a video. You can watch this later. But so my video doesn't solve a math problem. I'm just showing you how to do it. But you can see, I hold up my whiteboard so you can see how I did the problem. So make sure you watch your video and it's understandable. You have sound and you have information that you can see. So you can watch this later. You can make your video anytime, right? It's due April 13th. Okay, but only if you're down at PC7 will you not know how to do the math yet, right? So anyone who has a problem before that could do it. And that's another reason that I posted that early. Now, if you're wondering how to do a video, I have directions here. You could make a video on your computer and then just upload it here. That's an option. Or when you make the video, you can just click this icon right here. So for example, let me see if it'll even let me do it. If I click reply, I don't know if it'll let me right here. Right there, do you see how it'll let me make a video on my iPad? It right away lets me do that. But on your computer, it'll have a little icon that I show you right there. And you can just make the video right there in Canvas. Okay. It's real easy. It'll let you watch your video and everything. So this is a little bit different for you, right? So I want you to make sure you know how to do that assignment. Any questions on that? Okay, so should you only do one problem from the review when you study? No, you should do the whole review to study, yeah? So what are the videos for? What do you think? Why am I making you make videos? Any ideas?
To see if we understand the material, I guess. That's
so
why
you
they
can-
assigned us a
Yeah,
problem.
and so you can help each other too, right? Sometimes hearing it from me doesn't necessarily help you, but when you hear it from different students, it becomes more understandable. So sometimes the teacher isn't the best resource for you. It's another student that's a better resource for you. Okay. So you're going to do all the problems, but you only have to make a video on one problem, the one I assigned you. Yes. And you'll only be graded on the one you got assigned and then the response videos that you make. You can meet with me about your problem, right? But you can't just meet and go, I don't know how to do mine. Right? You have to come with something. Okay. And I'll help you with it. So any questions on that? Has anyone made a video before in Canvas? Yeah, some of you have. It's not very hard. Okay, so let's look at this second thing. Permutations, that's a big word, right? Permutations is a big word, but I want you to read through this. It says if we're asked to choose one item from each of two separate categories where there's m items in the first and n items in the second, then the total number of available choices is m times n. Sometimes this is called the multiplication rule of probabilities. That seem familiar to anyone? That's exactly what we said the basic counting principle was. Now we just have another fancy name called permutations. Okay. The only thing that's new here is sometimes they're going to tell us we can have repeats and sometimes we can't have repeats. Okay, that's what's new when we get to permutations, right? We could have done it with the other ones where we couldn't repeat as well. Okay, so let's take a look at this first one. Now, these questions are worded strangely, but this is how they're worded on more. So I worded them the same so you would have an example. It says, how many three-letter words can be made from these four letters? Oops, these four letters, if repetition's allowed and repetition's not allowed. So do you notice how I have words in quotes there? Because I'm pretty sure if I choose F, G, H, that's not a word, right? But that's what they're saying. They're just saying how many ways can we arrange these letters. Their statement of words is a little misleading, okay? So they're just saying how many ways can I arrange these letters? That's what they should say. So if we have 3 slots, because they're 3-letter words, and we have 4 choices for each slot, we're going to do 4 times 4 times 4. So that's going to be 4 to the 3rd power, which is 64. Does that make sense? Does that seem like what we just did? Yeah, it does seem like what we just did. And you could do it on your calculators if you want, right? And then how is the second part, part B, different?
You can't repeat any letters.
All right, that's totally correct. I can't repeat these letters. So if I can't repeat them, what am I going to do? I still have my 3 blanks, and I still have 4 choices for the first pick. Then how many choices do I have for the next pick?
3.
Yeah, I only have 3 choices for the next pick. And then the last pick, how many choices do I have?
2.
Yep, I have 2. So now I have 4 times 3 times 2, which is going to be 24. Does it make sense that I would have fewer choices if I can't repeat the letters? It should, right? Yeah. Okay. Now you guys try the next one. It's very similar, but now they tell you how many 4-letter words can be made from these 6 letters if repetition is allowed and repetition is not allowed. So get those 2 answers ready. If you're confused, you can ask me in the chat. Are you done with both of them or you need a little bit more time? Okay, nobody's screaming that they need more time. So I'm going to assume you're good. So let's just put our answer to part A in the chat. Okay, part A in the chat. Does everybody have part A ready? Okay, 3, 2, 1, go. Very nice. Excellent. So to get that 1,296, you just multiplied 6 times 6 times 6 times 6, or 6 to the 4th power. Excellent. Now get part B ready in the chat. Are you ready for part B? 3, 2, 1, go. Very nice. 360. Now tell me how you got 360. Did you have to divide anything? Or what did you do on that part? Ashley, what did you do on that part?
Do you divide it by the 6?
Is that what you did?
Yeah.
Yesenia, is that what you did?
I did 6 times 5 times 4 times 3.
Yeah, so why did you reduce it by 1 each time?
Because you can't allow the repetition of them. So you have to subtract it each time.
Yeah, so if you just took your answer from A and divided by 6, you wouldn't have gotten 360. You would have gotten 216, which, right, doesn't match. So the only way to get that 360 is you would multiply 6 times 5 times 4 times 3, because once I chose the letter out of the first one, then I don't have 6 choices for the next letter. I only have 5 choices for the next letter. And then after I have picked those 2 letters, I only have 4 choices for the next letter. And then after I've picked those, I only have 3 choices for the last one. Does that make sense, Ashley? You had the right answer, but I'm not sure your mathematics that you described isn't how you would have gotten that answer.
Yeah. Yeah, I get it now.
Okay. Jen Day, does that make sense? All right. Okay, now this is an interesting one. Tell me what you think about this question. A pianist plans to play 4 pieces or 4 songs at a recital. In how many ways can she arrange these pieces in the program? I want you to think about it. How many ways can she arrange those things in her program? So I'm going to give you about a minute to think. All right, so what do you guys think? Are we allowed to repeat or not repeat? What'd you get for an answer on this one? I know Valerie got it right because she shared it with me. AJ, Malachi, Angelina, any ideas? Ooh,
about
Angelina
24?
said the answer is 24. Anyone agree with 24? Amanda is shaking her head yes. Valerie agrees. Where'd we get, Malachi agrees, where'd we get 24 from, Angelina?
I just did 4 times 3 times 2 times 1.
Very nice. Why didn't you do 4 times 4 times 4 times 4?
Because it can't be repeated.
Yeah, you don't want her to play the same song 4 times in a row. Have you ever been to a piano recital? That sounds awful. And what would your program look like? Right? Like etude in G minor for the first piece, and etude in G minor for the second piece, and etude in G minor for the third place, and etude in G minor for the fourth piece. That is not a recital you would stay through, right? To hear the same song 4 times. So sometimes the problem doesn't specify if your repetition is allowed or not. You have to figure it out from the problem. Does that make sense? Okay, so sometimes it's a little tricky. Okay, there's one more example that we didn't get to, but that's okay. It's just saying how many ways can we get first, second, and third place. And this is the important part where it says assume a contestant can only win 1 prize. Then it would just be 210 times 209 times 208 because you can't win more than 1 prize. All right. You have a worksheet that's going to be due by tomorrow night. It's an assignment on Canvas now, and it's also in here, okay? But you're going to work on these problems independently. You're not going to have time in class to do them, okay? And everybody has to turn in one on Canvas by tomorrow night, because this will be a good way for me to give you feedback on, are you writing down the proper notation? And if you need any help before you take your quiz next week, okay? All right, so for homework, you have your handout that I just told you about. I didn't give it to you yet. It's on Canvas. You have PC More practice. That's going to be due Friday. And then you have your PC7 reading quiz and more lesson due on Sunday. Okay, so do your exit ticket and then have a great day. I'll see you tomorrow. I'll stay here if you have any questions. Jen Day, do you have any questions?